Hello, good students of radiology informatics. We're going to talk about ACK messages today. And this one's going to be a little bit longer than most of the videos. There's just too much stuff and it doesn't lend itself to being cut up in the middle or in sides, things like that. So this will just be a little longer. Just bear with me. So an ACK message starts with an originating message. The originating message is the message that starts the transaction. It's the message that's being acknowledged, and it can be an ADT, an ORM, or an ORU. Right? So an acknowledgement is saying, hey, we've received this message. So you can't have an ACK of an ACK. You can't have an ACK to an ORR. It has to be an ADT, an ORM, or an ORU message to get an acknowledgement message. The ACK message will always contain information about the message that is being acknowledged. Depending on which ACK mode is used, it may also contain information about whether the message was processed by the receiving system. Whether to use ACK messages or not and what mode to use is configured locally and can be both domain and interface specific. Test question. All HL7 messages are confirmed by an ACK message. You think that's true or false? That's false. Let's go back one. Whether to use ACK messages configured locally, right? So it's up to the PACS admin to choose which messages he wants to send acknowledgments for. So that question is obviously false. Interface sender configurations. When sending HL7 messages, the sender can be configured two ways. To wait for an ACK before sending the next message, to wait a specified amount of time before sending the next message, and this is called interface pacing. Okay, so one, you send a message, you wait for the acknowledgement before you send the next message to go out, or you send the message, you wait a specific amount of time, and then you send another message. So let's take a look at an interface in action. Okay, so hint, this is not an interface. This is actually a slide at Atlantis in the Bahamas. But it represents a good example of interface pacing. So the interface is red, right? And this is an ORU message waiting to go out the interface. Light goes green, out goes the next message. There goes the next message. That's probably a small ORM message. The message can't go until the interface light turns green. This is interface pacing. When the light goes green, the message goes. Now you see this guy here? He's monitoring the interface. But does he have any idea whether the messages actually get to their destination? Does he know if the message was received by the other end of the interface and it was properly processed? No. All he knows is the messages are going out and the interface is working. So here comes another message, probably another report. So that message just has to wait until the interface is clear. And green, the message can go. Oh, the message is stuck. The message got stuck. And here comes the next message. It just simply waits. And it's stuck. Well, it can't go. It can't go. It has to wait for the interface to be clear. And there it goes. Okay? So that is obviously not a real interface, but it's a good example of interface pacing. The messages just go out and you have no idea what's happening on the other end. So one, if you wait for an ACK before sending the next message, you know that the message was received because it was acknowledged. Interface pacing, you're not going to know if it was acknowledged on the other end. So, the drawbacks of interface pacing are no way to tell if the message was received or processed, and your interface log is useless because all it tells you is these messages went out. You don't know what happened on the other end. There are two modes of ACK messages. There is the original mode. In original mode, a single ACK message is sent back to the originating system. This lets the originating system know the message was received and processed. In enhanced mode, two ACK messages are sent back to the originating system. The first lets the originating system know that the message has been received. The second lets it know that it has been processed. And we'll talk about the advantages of that in a few minutes. So here's the originating message, goes out. It's an ADT, and it sends back an ACK that says, hey, we've acknowledged your AO1 message. We've received it and processed it. You get one back. Advantages of original mode is it's easy to build and implement, and it works well with point-to-point interfaces. Point-to-point interfaces are when two systems are connected directly by an interface, and it doesn't go through an interface engine. So if your packs in your voice recognition system are connected directly to each other and not through an interface engine, which is a common way to build your voice recognition system, original mode would be the way you would want to go with your acknowledgement, because it works well with point-to-point interfaces and it's easy to build and implement. Enhance mode. The originating message gets sent and two ACK messages are sent back. The first is called the commit or accept ACK, and it means the receiving system has taken custody of the message. The second is called the application ACK, and it means receiving system has processed the originating message. So here you have the ADT AO1 going out. First, it gets the commit acknowledgement, and then it gets the application acknowledgement. And even though there's two messages going back, right? If this system is waiting for an acknowledgement, as soon as it gets the first acknowledgement, it can send the next message to go out. So it actually works a little quicker that way. So the advantages of enhanced mode is it's faster. The sending system can begin processing the next message as soon as it receives the accept ACK, and enhanced mode works well with an interface engine. So if you have a whole bunch of systems working together through an interface engine, say you have RIS on one side and PACS on the other, and they're going to be sending a lot of messages back and forth, you would probably want to use enhanced mode because it actually does work faster. The ACK message segments. The ACK message can have 3 segments. It has MSH, the message header, which all messages have. It has MSA, the message acknowledgement segment, and error, the error code segment. So 3 segments are possible in an ACK message. An ACK message with no error code would have how many segments? The correct answer is B, 2. Okay, so if there's no error code, it will have an MSH and an MSA segment. You only get the error code when there's a error message. The correct answer to that question is B, 2. The ACK MSH segment. MSH 9.1 will tell you it's an acknowledgement message. MSH 9.2 will tell you what the originating message type is. MSH 10 will tell you the message control ID. The next to last MSH segment will tell you if this is a production or a test message. So here's your MSH. Here's MSH 9.1. You can see it's an acknowledgement, and it's an acknowledgement of an AO1. An AO1 would, of course, be an ADT message. Then you have the message control ID. This is a number that's specific to that message. And then you have the P or the T to tell you whether it's a production or a test message. The MSA segment. MSA1 is the acknowledgement code. There are 3 possible codes. AA, application acknowledgement. This means the message was received and processed. AE, application error. There was a processing problem with the message or its structure. AR, application reject. That means the queue is full or the application is down. Note the message may still be valid. Okay, so if it's good, it'll get an AA. If there's a problem with the message or the structure, you'll get an AE response. AR, application reject, means the queue is full. There's only so many messages in the queue and it can't process it. Kind of like the slide when it gets backed up. Or, you know, the application is down. If the RIS system is completely down, obviously the interface to the RIS doesn't work. So this is an MSA segment. You can see it has an AA, so that message was good. So here's the whole thing together. Here's the originating message as an order message. Okay. And so here you have the message ID for this order message. And then you have the acknowledgement. So here's the MSH, and it tells you it's an ACK to an 001, which in ORM is always an 001, right? It tells you that it's got acknowledged, and accepted with an AA, and it tells you the message that it gave the application acknowledgement to. It ends in 876, ends in 876. So this acknowledgement goes to this specific message if you look them up by the message ID. That's how that works. Thank you for watching.